Welcome, iPad Geometry Initiative class from OHS. This is Mr. Lane, your favorite iPad geometry teacher again. We'll be discussing section 2.6 over geometric proofs. How are you guys doing today, by the way?
Great, Mr. Lane.
Awesome, good to hear it. Good to hear it. So again, you in your notes want to write down the section number and the title. And we'll try and figure out some way to add in this number 5. Maybe you can just answer it. Yeah, go ahead and answer number 5 in your notes this time. We'll start including that in our notes to get a little higher level questioning. So, objectives today. You don't have to write this down, but we'll be discussing what is a 2-column proof. So are you guys excited about that today?
Yay!
All right. And then we'll prove geometric theorems using deductive reasoning. So when we're doing proofs, we're pretty much just using deductive reasoning. You guys remember what deductive reasoning is, right?
Yes, sir.
Alright, so deductive reasoning as a recap would be just something based off of facts, definitions, not patterns, because that would be inductive reasoning, correct?
Yes, sir.
Alright, sounds good. Let's go on and see what we're going to do on this lesson. So what does a proof show? Well, we're going to take a hypothesis and come out with a conclusion, and for each step in between we're going to come out, or we're going to list a justification for that. And those justifications are going to be definitions, postulates, properties, or theorems. And that would be the justifications we're looking at. Proof can use symbols, but must be clear enough so that anybody that reads it will understand what it is. Alright, moving on here. Here's the first type that we're going to do. I think they're going to write out kind of the proof for us, except for they're going to leave off the justifications, which would be definitions, properties, theorems, so on and so forth, that justifies each step in the problem here. So, let's see. We're supposed to write the justification for each step. Given that angle A and angle B are supplementary, you guys remember what supplementary means, right?
Yeah.
That would add up to equal 180 degrees. That is excellent. It looks like we're given angle A is 45 degrees. So let's look at it. We've got a little picture to go along with it. If they didn't give us that, we'd still be okay. By the way, if you don't have your properties from 2.5 or those other theorems readily available, you might want to look up some of those notes and start compiling those maybe into a folder that are just properties and theorems, and that way when the justifications come up you can kind of look to see what kind of choices you have here. So let's just do number 1 first. It looks like it has angle A and angle B are supplementary, and that measure of angle A equals 45 degrees. Now, it seems like I've seen that somewhere. Do you guys know where I saw that at, by any chance?
I don't know.
Up at the top?
Right up at the top. That is correct. It's right there in the given. So if we're given the information in the problem, and usually the first step of any proof is probably the given information. So we're just going to write given for that justification right there. So just about any proof that you see, no matter what style it is, you got to start from somewhere, and that's usually the given information. Alright, the next thing they say is the measure of angle A plus the measure of angle B equals 180 degrees. That sounds like the definition of something to me.
Supplementary.
Ah, very, very, very good, students. That would be the definition, and you can abbreviate on this stuff, should be alright. Definition of supplementary, and I'm going to abbreviate, oops,
That's
supplementary angles. Alright, very good job so far. Let's keep on going down. Looks like they changed the measure of angle A to 45 degrees. Let's see, we're given the measure of A is 45 degrees. So what property allows us to put it in to the equation? What property would that be when we take something and plug it into the equation?
Substitution?
Yes, that would be substitution. Very good. You guys are doing wonderful today. A little bit more active than usually we are in the mornings. Thank you, Mr. Lane. All right.
Thank you, Mr.
Oh, yeah, thanks. No problem. All right, so then it looks like we've got to take the 45 and bring it to the other side. So what property allows us to take something and move it to the other side? If it's being added, the opposite would be?
Subtraction.
Yes, that is absolutely correct. So the last justification, notice that all they did to get to that step is they subtracted the 45 from both sides. So we're going to list that as a subtraction property. I'm going to abbreviate that a little bit, of equality. I'm going to use a symbol for equality as the equals right now. So notice that all we did was fill in the justifications of each step. That's how they're going to get you used to doing proofs here. Looks like we have another one. In this particular one, it looks like we're supposed to write the justifications given that B is the midpoint of segment AC and that segment AB is congruent to segment EF. And again, we've got a picture down here, but if we didn't, we could probably draw one and be fine. Alright, so let's see. B is the midpoint of AC. I've seen that somewhere, and in the last example, our first justification was the given. Very good. Excellent job. Yes, the given is usually your first step. So you might look to see your given information and make sure it matches up with that first step just to check. That one looks kind of familiar, but it's not in the given information here. But we are given that, and the first step here is that B is the midpoint of AC. Well, midpoint tells us something. What does midpoint mean in a segment? Well, yes, it does mean that it cuts it right in half. So if it cuts it right in half, that would make this congruent to that, which notice is segment AB is congruent to segment BC.
Yes,
so
sir.
what that would be definition of midpoint. So notice it was kind of related to that information that was given, and that's why they listed that part of the given information right above it, because they were going to use it. Alright? Now, I've seen this statement 3 somewhere before. I can't remember where I saw it, though. Do you guys happen to notice it somewhere? The given information right at the top. That is excellent. So again, my justification for this part is just given. Very good job, students. Alright, and then I think we've got a step 4 here. And let's see, they've got a BC, which this is kind of like an equals here. So they're making this statement here, they're just replacing it, it looks like, with the BC. So yeah, when they take something and they plug it in for something else, substitution again. Now I hear you, you could make a case for the transitive property right there, which, you know, if you have A is equal to B and then B is equal to C. But I think in this situation, all they're doing is go ahead and plugging that BC in for the AB. So I'm going to call that substitution. But very smart. Very good job. Regular geometry class would be doing these problems right now. iPad students, you can go ahead and continue. What a theorem is any statement that can be proven true, and it becomes a theorem once it is proven true, and then we can use it in any proof after that theorem is proven true.
That's amazing.
Yes. So let's see, theorem 2.6 is a linear pair. Now, if it has a name, it's kind of important, and we don't need to call it theorem 2.6-1 anymore. We can just call it the linear pair theorem. And this says if two angles form a linear pair, then they are supplementary. Now remember, linear pairs is just two angles that are adjacent and they form a straight line, right?
Correct.
Very good. So notice that if they add up to equal a straight line, they are supplementary. So that would be something that could be proven. The other theorem here is 2.6, which is the congruent supplements. It says if two angles are supplementary to the same angle or to two congruent angles, then those two angles are congruent themselves. Okay. So in other words, let's say I have angle 1 here, and I have angle 2 sitting right there. Alright, notice, yeah, that those are adjacent. They form a linear pair, so angle 1 and angle 2 would be supplementary. Now, if I had another angle that I knew was congruent with angle 2, let's say angle 3 here, if these two are congruent, then angle 1 and angle 3 would also be supplementary. Alright? Alright, let's move on. So what do we do in a proof? Well, we've got some steps here. We list the given information. We use the information from any diagram that we need. We give a reason for each statement, which we've kind of looked at that already. And then use the given information, definition, postulates, and theorems for those reasons. So that's what we're doing in a proof. Now the main proof that we see is a 2-column proof. And in a 2-column proof, we organize it to statements on the left-hand side and reasons on the right-hand side. And each time we list a statement, we just list the reason along with it. And generally speaking, we start with given for the reason, and then what we're trying to prove is usually that last statement underneath our statement side. So 2 of these things, or actually 3 of these things, because this will be the given information here, and then the given is the reason, and usually what we're trying to prove goes in the last step. So basically 3 of those things in a 2-column proof sets itself up. Okay? So some of it already takes care of itself for you. I think before we start this one, I'm going to go ahead and conclude part 1 of this video. We should just have 2 parts to this video, but I want to thank those students that did come in to help us out this morning. So thank you guys very much.
You're welcome, Mr. Lane.
Oh, stop it. Alright, this will conclude section 2.6, which is over geometric proofs. Signing off from OHS High School. This is Mr. Lane.